So as you can see, as soon as I configure router 0 and I issue the no shutdown command to bring the interface up and the protocols, both of them are up and up. Next I will configure the route. That's going to be IP route, the static route that is. Now from router 0 we have a route to the 30 dot network, and to get there we need to, we can look at the drawing if it helps. 20.0.0.2, that's how we get to route 30. So 20.0.0.2. At this point we can issue a show IP int brief command and see that, paying attention here, that our fast Ethernet has an IP address, and both is showing up, and so is the serial interface, up and up. And if we look here, we can see that we have green link lights now, meaning that we have connectivity across the two routers. And why not? We can issue a ping, see if we can get from here to here. And yes, as you can see, the ping was successful. We should be able at this point to ping across from PC1 to PC0. Let's try that. I'm going to send that ping, and it failed. Remember I said sometimes the first time it fails. Let's try that again. Fails again. So what could be the problem? Let's look at the IP address of the fast Ethernet. It's 10.0.0.1/28. And what's the IP address over here? It's 10.0.0.10/28. Now we do not have a problem with the network now, so the problem must be something different. Well, let's take a look, see what's going on. Serial, let me see, serial 00 is 20.0.0.1. That's right, /30. Let's look at router 1. 10.0, so that should be 20.0.0.2. That's a problem. So let me change that IP address. Okay, I've changed the IP address. Let's see. Now it's 20.0.0.2 on router 0 is 20.0.0.1. Let's try pinging it again. From router 0 to router 1. And now the ping is successful. Let me clear this out. And we can try a ping across the network from PC0 all the way to PC1. And what do you know? Successful. We can do it the other way too, just to make sure it works, although I knew it would. So that's also successful. Alright, Packet Tracer allows us to slow down time and capture and analyze frames and packets as they travel across the network. As an example, I'm going to ping these two computers and press the capture and forward button so we can analyze the packet. As you can see, fast Ethernet 00 receives the frame. We're looking at layer 1. I'm going to advance to the next layer. The frame's destination MAC address matches the receiving port's MAC address, the broadcast address, or the multicast address. The device decapsulates the PDU from the Ethernet frame. Next layer is layer 3. The router looks up the destination IP address in the routing table. Let's move on to layer 3 in the outgoing. And the routing table finds a routing entry to the destination IP address, and the router decrements the TTL, or time to leave, on the packet. Let's look at here we can see that it's going to be an HDLC frame. It's going to be going out the serial interface to the next hop, which is another router. This is the inbound PDU, and this was an ICMP ping request from PC0 that it's now at router 0. Alright, the device encapsulates the packet into the HDLC frame and sends the frame out. So it goes out to the next hop, and we can see there that the incoming packet, the serial 00, receives the frame. Next layer tells us that the device decapsulates the payload from the HDLC frame and sends it to the upper layer, or layer 3. In layer 3, the router looks up the destination IP address in the routing table. The routing table finds a routing entry to the destination IP address. That's layer T of the outgoing packet. The destination network is directly connected. The router sets destination as the next hop. The router decrements the TTL one more time on the packet. The next hop IP address is a unicast. The ARP process looks it up in the ARP table. The next hop's IP address is in the ARP table. The ARP process sets the frame destination MAC address to the one found in the table. The device encapsulates the PDU into the Ethernet frame. Fast Ethernet 00 sends out the frame, and it reaches PC1. Let's double click on it, and basically you can see the steps again, the in layers and the out layers of the packet. Alright, we were able to ping from PC1 to PC0, and we established that there is connectivity between one side and the other. Let me do a show IP route command, and we can see that S right here, it's for static route, static, and C is for connected. So we're connected to this is router 1, by the way. We have a static route to the 10 dot network, and we are directly connected to the 20 dot and the 30 dot networks. If we go to router 0 and issue the same command, show IP route, we also have we can see we're directly connected to the 10 dot network and the 20 dot network, and we have a static route to the 30 dot network. And this concludes the presentation on how to configure a static route.